Every so often, science doesn't just add a new fact to the pile. It completely kicks the whole pile over. And wow, 2025 has been one of those years. We've seen a handful of discoveries that are forcing us to rethink some of our most basic ideas about the universe and, well, our place in it.
So that's really the big question we're tackling. What if the things we thought were settled just aren't? We're going to dive into 3 incredible stories where the rulebook is basically being thrown out the window. From the dawn of time to the fate of the entire universe, and even deep, deep beneath our own feet.
All right, let's start at the very beginning, in the deepest, earliest corners of the cosmos. The James Webb Space Telescope has been peering back to the universe's infancy, and it found something, well, something that just shouldn't be there. Hundreds of these strange objects that astronomers started calling little red dots. And they're red because their light has been traveling for billions of years, getting stretched out as the universe expanded. It means we're seeing them as they were when the universe was just a baby.
And this quote, it just nails the reaction from scientists. It wasn't just excitement, it was genuine confusion. Like, what on earth are we seeing? These things didn't fit any of the models. So for 2 solid years, researchers were scrambling, pointing Webb at them again and again, just trying to figure out the mystery.
And then, in 2025, they cracked it. They finally identified one of them, an object called QSO-1. And the answer was just staggering. They were looking at a supermassive black hole with the mass of 50 million suns. And the crazy part? It was basically just floating out there, all by itself in the early cosmos.
This right here shows you just how bizarre this thing is. In every galaxy we've ever seen, including our own Milky Way, the big black hole in the middle is just a tiny, tiny fraction of the galaxy's total mass. But QSO-1, it isn't a fraction. It is the mass. It's so huge compared to everything around it that some astronomers have started calling it a naked black hole. There's almost no galaxy to speak of?
And here's the kicker. This completely flips the script on how we thought galaxies were made. The old story was simple. A galaxy forms, stars are born, and then, over billions of years, a black hole slowly grows at the center. But the gas around QSO-1 is just hydrogen and helium, the pure primordial stuff left over from the Big Bang. That means no stars had formed yet. The black hole must have come first. So these cosmic monsters might not be the children of galaxies, they might be their parents.
Okay, so from the universe's birth, let's jump all the way to its ultimate fate. Our next story is all about dark energy, that mysterious force that's pushing everything apart. For decades, we thought we had a pretty good handle on it, but it turns out we might have been very, very wrong.
For the last, 27 years or so, this idea, the cosmological constant, has been the bedrock of our standard model of the universe. It's an elegant idea from Einstein, really. It says dark energy is just a constant property of space itself. It pushes, and it always pushes with the exact same amount of force. But now, new data is starting to poke some serious holes in that idea.
So using this incredible instrument called DESI, scientists have made the biggest 3D map of the universe ever. In 2024, they got the first hints that dark energy might be weakening, that the cosmic expansion was actually slowing down. The data hit a confidence level of 3.5 sigma. Okay, interesting. But then, with 3 times more data in 2025, that confidence jumped to 4.2 sigma. The signal didn't go away. It got stronger.
To put that number in perspective for you, a 4.2 sigma result means there's only a 1 in 30,000 chance that what they're seeing is just a random statistical blip. That is significant. It's not quite a discovery yet, but it's a piece of evidence that's becoming really, really hard to ignore.
And that's the key, right? In physics, the gold standard for a discovery is 5 sigma. That's a 1 in a million chance of being a fluke. So even though multiple data sets are pointing in the same direction, scientists are being super cautious, as they should be. They are checking and rechecking everything before they declare the standard model of cosmology officially broken.
But you can feel the excitement building. This is such a thrilling time for cosmology. The rulebook is officially open for revision. And the next generation of telescopes, like the Vera Rubin Observatory, are about to unleash a fire hose of new data that will help us write the next chapter. So, is dark energy constant, or is the universe slowly but surely running out of gas?
For our last story, we're coming home. We're zooming in from the very edge of the universe to the dead center of our own planet. For a long, long time, we pictured the boundary between Earth's molten core and its rocky mantle as this sharp, clean line. But new evidence is telling us it's a much more dynamic, interactive, and frankly, a much messier place down there.
So in 2025, 2 completely separate lines of research, pointed to the same radical conclusion. First, you had seismologists looking at these two continent-sized blobs at the base of the mantle. They realized earthquake waves passed right through them without losing any energy. Weird. Then, totally independently, geochemists found a specific type of atom, an isotope, in volcanic rocks that had one and only one possible origin, the Earth's core.
The journey here is just incredible to think about. See, this stuff, ruthenium-100, it loves iron. So when the Earth was forming, all of it sank right down into the core. Finding it in volcanic rocks up here on the surface, that is the ultimate smoking gun. It means that material is somehow leaking from the core, getting swept up into these mantle plumes and traveling 3,000 kilometers up to get blasted out of a volcano.
So why does any of this matter? Well, because this interaction, this leaking, churning engine, is very likely what keeps our planet geologically alive. It helps drive plate tectonics and that churning mantle, the very processes that regulate our planet's temperature and make it stable enough for life. Just look at Mars. It has a static, dead mantle. Earth is alive, and that life might be thanks to this deep, hidden connection to its own core.
So let's step back for a second. We've got a leaking core, fading cosmic energy, and bizarre naked black holes. These are three completely different fields of science, and they're all arriving at the same exact place, finding that the neat, tidy models we've relied on for decades might just be wrong.
Whether we're talking about black holes birthing entire galaxies, dark energy fading away, or our planet's own core actively shaping its surface, the fundamental story of how things work is changing right before our eyes. And that's what makes science so amazing, right? It's not a dusty book of facts. It's a process of constantly questioning those facts. It really leaves you with a fascinating question to chew on. If these huge, foundational ideas can be turned upside down in a single year, what else do we think we know for certain that might turn out to be completely wrong? What big truth is just sitting out there waiting for the right instrument or the right mind to challenge it next?